Hello guys, welcome to another video. This one is paper 4.2 of May-June 2020 for paper Mechanics M1. Okay, so let's move on to the question number 1. So a tram starts from rest mean at v equal to 0, you have to know that, from rest, and moves with a uniform acceleration for 20 seconds. So 20 seconds. Now the tram then travels at a constant speed v meters per second for 170 seconds before being brought to rest with a uniform deceleration of magnitude twice that of acceleration. Now we know this. The total distance traveled by the tram is 2.775 km. So because everything here, you can see the speed is in meters per second, meters, we first have to change that to meters. So we know that 1 km is equal to 1000 meters. So this will be 2.775 meters. Okay, that is something we have to do in the question. Now, question part 1. Sketch a velocity time graph for the motion, stating the total time for which the tram is moving. So we have two parts. First part is to sketch this graph and then state the time for which the tram is moving. So as you can see, we have velocity time graph. This is your y and this is your x. So we have to draw the axis. So let's do that. So this is your y and your x will be on this way. So always label the axis. It is very important. So let's do, for this one it will be, this is your velocity for y. That will be v. That will be meters per second. And x will be your time per second. Okay, that will be your axis. Now the thing here is we have to look at this part by part. Okay, don't get confused, always start with part by part. The first thing we know is that the tram starts from rest, so from this point, moves with a uniform acceleration for 20 seconds. So 20 seconds, let's say 20 is about here, for example. So let's mark this as 20. And then it moves with a uniform acceleration. So when you have a velocity time graph, the gradient is equal to the acceleration. So that's why it has to be a straight line. Let's say, for example, v is about here. So we have to join these 2 points by a straight line for uniform acceleration. So let's just mark this point so they can see clearly your values on your graph. Okay, so that is your estimation for your value of v. Okay, so now the first part is done. Now the second part is the tram then travels at a constant speed v, the same speed, for 170. So after 20 it travels for 170, so you have to add that to 20. That will be for 170, that will be about 190. So let's do that. 170 plus 20, that will be 190, just to check. So that will be the time for which it travels at a constant speed. So let's mark this as well. Okay, and let's join this with a straight line for your constant velocity. And part 2 is done. Now part 3, before being brought to rest means v0, with a uniform, again, uniform means straight line, deceleration of magnitude twice that of the acceleration. So if your acceleration took 20 seconds, since it is twice the size of the acceleration, it will take 2 times less. That will be taking 10 seconds. So it will be about, let's say about this value. It will take 10 seconds, so you have to be drawing a straight line, and that will be 200. So that will be your velocity time graph for this tram. So you have to mention this. The tram has been moving for 200 seconds. So whenever you have this kind of question, you have to take everything piece by piece and then draw on the graph. So that will be for part A. Now for part B, we have to find the value of v. So To find the value of v, we have to look at the information that we are given, this one, to find the value. So whenever you have a velocity time graph, you have to know that distance traveled, so distance travel is equal to area under graph. So this, you know already, is given to you as 2775. And now you have to observe what is area under graph. It is area of a trapezium because these two sides are parallel and the distance in between has been given to you as well. So how do you find area of trapezium? So area of trapezium, it is equal to half times sum of parallel sides. So these two sides are parallel. So this length here is 200 plus this one is this minus this, that will be 170, and times the height in between, which will be v minus 0, which is, we don't know, which is v, right? So we have to simplify. So 200 plus 170 divided by 2, that will be 185 v. So on the right hand side you will have 185 v. So now we have to solve for v. V finally will be 2775 divided by 185. That will be 15, will be your value of v. Now the thing is, let's say if you forget what is the formula of a trapezium in exam, you can always look at this shape piece by piece, right? You can break this down. Let's say you can break this down as a, b, and c. If you forget your formula, you can always find the area of triangle, of rectangle, and triangle. You should get the same values. So we can try if you want to. So if you look at a, it is triangle, it is half times base, which is 20, times height, which is v, plus this one is 170, it is the area of rectangle, and times height, so 170, times v, and finally plus this one is also a triangle, half times base, which is 10, and times height, which is v. Simplified, that will give you 10. So 10v plus 170v plus 5v, that will be 185v. So same thing, but two different ways, you will get the same value of v equal to 15. So that is just in case you forget your formula. You can always look at piece by piece to find the area under the graph. Now finally, part C, find the magnitude of the acceleration. So you can use your formula if you want to. Acceleration is equal to final speed minus initial speed over time taken. So final speed is v is equal to 15 minus initial is 0 divided by time taken. This is given to you as 20. That will be 20. So 15 divided by 20, that should be 0.75, and mention your units, meters per second square. Now also one thing it is useful to know is that whenever you are asked to find the acceleration in a velocity time graph, the acceleration is always equal to the gradient of a right angle triangle. So if you see, here we have a right angle triangle. And how do you find the gradient? You will take the height of the triangle, which is 15, and divide by the base. So you will get the same value for the accelerations. So that is two ways of finding the same answer. And that will be your question number 1. Now let's move on to question number 2. Now we have coplanar forces of magnitude 20 Newton, P Newton, 3P Newton, and 4P Newton act at a point in the direction shown in the diagram. Now the system is in equilibrium, so that's the main point here. This means that the forces are the resulting force are equal to each other, or it is 0, basically what it means, equal. Okay, so let's first, what can we do here in those questions is we have to break it down into their components for each of the forces. So basically we have to know what are the components in those direction, in the left, in the right or left, in the north or south. So we only need forces in those 4 directions and not at this angle direction. So we have to break it down one by one. So this one we can break down to, it will be in this direction. So if you guys did physics, you guys would know how to break down this force into its components. But if you guys did not do physics, let me just show you one example. For example, here you will have, let's say you have the axis just like that, and you have a force acting in this direction. Let's say in this direction. Okay, so that is a force acting in this direction. Let's call it let's use 10 Newton. Now if you want to break this down into its components, let's say I will give you an angle is theta. So the components of a force is always going to be either in this direction, up, left, or down. But in this case, you can see since the force is this way, it will have these two components. Now to break it down, the force in this direction, let me use a different color here. The force in this direction, so it will be the one which is close to the angle of theta. It has to be 10 cos of theta. So just to remember, if it's close to the angle of theta, close is C. So when you write close, you have to write C. You have to use cos. So in that way, you write this direction will be 10 cos of theta for the component in this direction. Now for the other direction, we have only one other option. It will be 10 sine of theta. So proceeding the same way, let's say for example this one, you will have two components because your force is in this direction. We will have to have something like this and something like this because your resulting force is in this direction. Now this one here, you can see it is close to the angle of theta. It will be called, this one will be called 20 cos of theta, and this one will be called 20 sine of theta. So same way, this one, it will have to be in this direction. So this one, it will have to be called, since it is close to your angle of 30, so we have to use P cos of 30, and the one in this direction will be P sine of 30. And for this one, it will be in this direction and up, right? So the one close to the angle, it will be 3p cos of theta, and this one will be 3p sine of theta. So right now, by doing that, we only have forces acting down, up, left, or right. So in that way, we can evaluate these forces and find the value of P and theta. So the main point here is the forces. So the main point here is the sum of the forces on the horizontal axis will equal to 0. It means that the force that acts in this way, it has to equal to all the forces acting in this way. So let's write this down. So how many forces we have in this way? Let's count. We have this and this. That will be P cos 30 plus 3p cos, this is actually the angle theta, because here it is not theta, it is 30. We have to write 30. Sorry about that. Okay, it's 30. So in this direction will be 3p cos 30. So that's all we have in this direction. And how about this direction? It is equal to this direction, which is 20 cos of theta. That is the only thing we have in this direction. Now we have an equation. Let's try to simplify it. So what is cos of 30? Cos of 30 is equal to root 3 over 2. You can verify this on your calculator as well. You will find the same value. Okay. Now replace. You have p times root 3 over 2 plus 3p times root 3 over 2 is equal to 20 cos theta. Now these two, you can add them together. They also have the same base. So we have the base of 2. So p root 3 plus 3p root 3, that will be 4p root 3 is equal to 20 cos of theta. Now this one can simplify to 2. You will have 2p root 3 is equal to 20 cos of theta. So simplify. P root 3, that will be 10 cos of theta. Okay, that will be your equation number 1. So now we found all the forces in the horizontal direction. Now let's find the one in the vertical direction. Let's observe. Let me use a different color for this one. I'll use brown. So we have to know that the sum of all the forces in the y direction, in the y-axis, the vertical axis, is also 0. So let's see how many forces we have going up. We have this one and this one, and that's it. So we have 2 forces which is going up. So we have 3p sine of 30 plus 4p, and that is equal to all the forces going down. Down we have this one and this one. So 20 sine of theta plus p sine of theta. Now we can simplify. You will have here what? You will have, so first thing to know is what is the value of sine of 30? That is equal to half. Okay, so here again you see I made a mistake because I have to write, because we know the angle here, that will be 30, not theta. Okay, so that will be 30 here. This is forces in the downward direction. Okay, so if you simplify, you will have what? 3p times half plus 4p equal to 20 sine theta plus p times half. Now we have to set all the p to one direction. You will have 3 over 2p, so write down 3 over 2 plus 4 minus 1 half. That should be 5. So you have 5p equal to 20 sine theta. So p is equal to 4 sine theta. That is equation number 2. Now since we have 2 equations, you can see we can solve them simultaneously. Replace p into p here. So you will have 4 sine of theta root 3 is equal to 10 cos of theta. So basically you will have 4 root 3 sine theta is equal to 10 cos of theta. Now when you're solving an equation like this, when you have sine and cos in the same equation, you have to divide by cos theta. So you will have 4 root 3, that will become 10 because sine divided by cos is 10. This one is 10. So tan theta is equal to 10 divided by 4 root 3. So let's find the value of theta. So 10 divided by 8 root 3, sorry, 4 root 3, that will be 55.3 degrees. And using this value to find the value of p is equal to 4 sine of theta. So we have sine of the answer times 4. That will be 3.29 Newton, correct to 3SF. Now, how do you know this value is correct? Because you can see the value here is acute angle, so it has to be less than 90 for the value of theta. So theta is this, p will be this value. But the main point in this question is you have to know how to break down your forces into its components, which is only in those direction, and then you have to equate saying that all the forces in the left is equal to all of one in the right, and all the forces on the top is equal to all the forces at the bottom. By doing that, we can form these 2 equations and then solve simultaneously to find those 2 answers. And that will be your question number 2. Now let's move on to question number 3. So here we have a particle of a mass 2.5 kg is held in equilibrium on a rough plane inclined at 20 degrees to the horizontal by a force T, making an angle of 60 degrees with a line of greater slope of the plane, as you can see on the diagram. Right. Now we have also here the coefficient of friction between the particle and the plane is this. Usually we'll call this the value of mu, which is the friction between the particle and the plane. Now the question is to find the greatest and the least possible values of t. So how can we find those 2 values? So because we have 2 possibilities, that's why we can have 2 values. So one possibility is the particle can either move up or it can move down. Because of that, we will have two possibilities of the value of t. So let's start with the first case. What if the particle move up the slope? Right? Now, before we begin anything, we have to break down their forces into their components as we did it in the question number 2. So let's do that again. So this one, let's break this down. So we have to break this down relative to this plane, okay? So we have to assume that the plane is a horizontal place, and we have to break it down according to the plane. So as always, we have vertical forces, and we have horizontal forces as well, okay? Okay, so let's break them down piece by piece. So for this one, it will be, so that will be your value of, so first thing, let's write this down. So because we cannot, the mass has been given to us by 2.5 kg. Here we only work with forces, so weight will be 25 Newton. So we have to work with the weight. So the force in this direction will be 25 cos of the angle, which is 20, and this one will be 25 sine of 20. Okay. Now for these ones, this one the force is in this direction, and this one is close to this side. This will have to be your t cos of 60, and this one is your t sine of 60. Also, whenever you have something against a surface, we have a reaction force called N. This is N, okay? Now, since we have all these components, we can solve the equation. So, if you guys want to know how did I break these two down, I will show you right here, okay? So basically what happens is I have my ground, which is at 20 degrees to the horizontal. I have this plane here, right? And the particle is on this plane, right? Let's say it is right here. So now we have the mass is 2.5, the weight is 25. So 25 is acting directly below, downwards, right, in this direction. So 25 Newton. That is the direction of gravity. That's why the weight acts directly downwards. So now we know the angle here is 20 degrees. So our job is to break this down, break the components of this force into its components relative to the plane, to the left or right, or down or up, right? So in this case, since the resulting force is in this direction, my components will have to be downwards and also in this direction. Okay. So because this angle is 20, this angle here has to be 20 as well. Okay. Now to break this down, this side is close to the angle, so it has to be 25 cos of 20, and this side will be 25 sine of 20. So that's how I break this one into these two components. Okay, that will be all the forces acting on the particle. Now let's do case by case. The first case, as you can see, we assume that it will move up the slope. So going up, you will see we have this force going up, which is in this direction. That will be force T cos of 60. But also you see we have also this force acting in this direction. This will be 25 sine of 20. Now since we assume that it is going up, we will have also the friction acting in the opposite direction of the object, of the movement. Now we have to look at this. It says equilibrium. It means that the force, the resulting force is always going to be 0, which means the force of going up is equal to the force of going down. So we have to write down T cos of 60 is equal to F, which is the friction, plus 25 sine of 20. Now from here we have to simplify. Cos of 60, as you know by now, it is 0.5. So you will have 0.5t is equal to friction is equal to what? You have to know this. It is mu times n or times r, up to you. So let's write down F is mu. Mu is this one, 0.3, n plus 25 sine 20. Make sure your angle is set to degrees so you can find the right value, okay? 8.5505. So now next thing is we have to find the value of n, right? Because we want to find t for when we go up the slope. So how do you find the value of n? Look at your drawing here. You can see that the resulting force here is equal to this force here because it is in equilibrium. So let's write this down to find the value of n. So here we have the equation of t sine 60 plus n is supposed to give you 25 cos of 20. So n has to be, what is 25 cos of 20? That will be 23.49 minus sine of 60 will be 0.866 t. That will be your equation to find the value of t. Now let's replace that back in the main equation you will have. So here we have 0.5. T is equal to, we don't know yet, is equal to 0.3. N is equal to 23.49 minus 0.866 t plus 8.5505. Now expand the brackets, you will have 0.5 t equal to 0.3 times 23.49. That will be 7.047 minus 0.3 times 0.866, 0.2598 t plus 8.5505. Okay, so let's see what else do we have. So send t to one side, you will have 0.5 plus 0.2598, that will be 0.7589. That is t is equal to 7.047 plus 8.5505. That will be 15.5975. So finally, the value of t will be this divided by 0.7589. That will be equal to 20.55, or you can write down correct to 3SF, 20.6 Newton. So now we don't know if it's the maximum value or the lowest value, but that is one of them. That is when you go up the slope. Now the other option is if you go down the slope, right? So option number 2, if you go down the slope. Now same thing, we have to look at our drawing. If you go down the slope, we have a force here acting, which is 25 sine of 20. And the upward force is also the same, which is t cos of 60. But since we are going down the slope, the friction will be opposite direction. So here we have another equation we can form. Because it is in equilibrium, the resulting force has to be 0. So the upward force is equal to the downward force. So t cos of 60 plus F is equal to 25 sine of 20. Now simplify to see what we have. So here we have the same values, we can just replace. So let's do step by step, let's not get confused. So t is 0.5t plus F is equal to 0.3n. So let's write this down. Is equal to 8.5505. Now we have to find the value of t. So value of n was given to you by this one. We can replace. You will have 0.5t plus 0.3 times n, which is 23.49 minus 0.866t equal to 8.5505. Now let's move forward by expanding this. You can see already the expansion. So we have 0.5t plus, that should give you 7.047 minus 0.2598. 0.2598 t equal to 8.5505. Now simplify the t's, you will have 0.5 minus 0.2598. That will be 0.2402 t is equal to 8.5505 minus 7.047. That will be 1.5035. Finally, this divided by 0.2402, that will be 6.23 Newton. So, as you can see, we have two values of t. The first value is 20.6 and this one is 6.23. So the max value, the greatest value, t is 20.6 Newton, and the least value of t is 6.23 Newton. And that will be your question number 3. But the most important thing to remember when doing this question is to draw your all the components that you know of your diagram, and based on that your answers will be step by step following the diagram. So that will be question number 3. Okay, so let's move on to question number 4. We have small smooth spheres A and B of equal radius and masses 4 kg and 2 kg respectively. Now they lie on a smooth horizontal plane. So initially B is at rest and A is moving towards B with a speed of 10. Then after the spheres collide, A continues to move in the same direction but with half the speed of V. So in those questions, let's make a drawing because it might be confusing, so it's always best to make a diagram to understand what's happening. So here we have A and B. This is A. Let's call this one A. And we have B. Now the mass of A is given by 4 kg, and the speed, this is mass of A, and the speed is given by at first in this direction towards B is given by 10, and the mass of B is given by 2 kg, and the speed is 0. That's the initial speed, right? Now this is not moving, and afterwards, after they collide, what happens is A continues to move in the same direction, so with the speed which is half of B, so half of speed of B. This B and this is A. Okay, this is A, and then B moves in this direction as well, and the speed of B we don't know. Now, so having all this information, when it comes down to collision, the only thing that we need to think about is momentum. Now, how do you define momentum? Momentum is equal to the mass times the velocity. Okay, so what are we trying to say here is that momentum is always conserved. So momentum is always conserved. Just like energy, it doesn't change, is conserved, and that's why we say initial momentum will be equal to your final momentum. So that's the equation that we need to form to be able to find the value of the speed of B. Okay, so at first here we have momentum is mass times V, so we have m mass of A times speed of A plus mass of B times speed of B, and that is equal to the mass of A as well and speed of A plus mass of B times speed of B. So let's change that to U, because as we know, we call U your initial speed and V your final. That's why it's better not to get confused. Let's just replace that by U, and here we have V. So observe, m is 4, A is given by 10, plus this will be 0, is equal to m is this is A, of course, that will be m is same, which is 4, and as we have seen, the speed of A is half of B, so replace by half of VB, plus m, it is 2, and VB. Now let's simplify to see what happens. So here we have 40 is equal to 2 VB plus 2 VB. So let's simplify. You have 40 is equal to 4 VB. So finally, VB is equal to 10. So the speed of B is what we need to find after the collision will be 10 meters per second. That is your answer for part A. Now let's move on to part B to see what's happening now. Now we have a third smooth sphere C of mass 1 kg with the same radius is at rest. So the initial speed is at rest on the plane. Now B collides with C directly. After the collision, B continues to move in the same direction but with 1/3 of the speed of C. So as always, let's make a drawing so we can understand what's happening. So C at first, it doesn't move, it's at rest. So we know U is 0 and the mass was given to be 1. Now B comes and hit C. This is B, and the U, as we have seen here, is 10, and the mass of B is equal to 2. After they hit each other, B continues in the same direction, but its speed now is 1/3 of the speed of C. Speed of B. Now C moves in this direction, but we have the speed of C that we don't know. We need to find that. So the main question is, show that there's another collision between A and B. So to know this happens or not, we have to find VA and VB after B hits C. So let's first find the speed of C to be able to find the speed of B and then find that answer. Okay, so let's do that one by one. So same steps. The initial momentum is given by mass of B times initial speed of B plus mass of C times initial speed of C equal to mass of B times final speed of B plus mass of C times final speed of C. Now replace, this one will be 0, this will be 2 times 10 equal to, this is 2 times 1/3 VC plus mass is 1 and VC we don't know. This will be 20 equal to 2/3 VC plus VC. And that will give you what? Let's simplify. That will give you 5/3 VC. So finally, VC is equal to, divide by 5, it will be 4, then cross multiply, you will have 12 meters per second. So the speed of C is 12 meters per second. So we can find the speed of B. So as we have seen, speed of B is 1/3 the speed of C, which is 1/3 times 12, and that will be 4 meters per second. That is your speed of B. Now going back to your first part of the question, it tells you that after the collision, A continues to move in the same direction but with half the speed of B. So basically, from here you can see that the speed of A will be half, which is 5 meters per second. So now to answer the question, if they can collide, we have to compare the speed. We have speed of B is equal to 4 meters per second and speed of A is equal to 5 meters per second. So basically, they are both going the same direction. Right now B is here with and A is here. So since the speed, you can say since the speed of A is more than the speed of B, so eventually A will catch up with B, so A will collide with B because of that. Okay, and that is your answer for part B of question 4. Now for part C, we have A and B coalesces during this collision. So what does coalesces mean? It means that they become one body. So basically, instead of having two separate, they becomes close and move in the same direction. We assume that they become one body. So what is the mass of A and B? You have to add them together. It will be 6 kg. That is something to know for the question. Now the question is asking us to find the total loss, the loss in kinetic energy in the system due to the 3 collision. So how do you find loss of kinetic energy? So you have to first find the initial kinetic energy minus the final kinetic energy. Of course, I hope you guys know the formula for that. So kinetic energy is equal to half times m times v squared. So at first, as you can see from part 1, for the initial kinetic energy, only A was moving, right? So basically, half the mass of A was given to you by 4 and the speed by 10. That will be 200 joules at the beginning. Now we have to find the final kinetic energy. So to be able to find that, we have to understand, we have to find the speeds of them when they move together, right? So what happened was, we had on one side, these two was moving in the same direction, as you can see. So we have m of A and u of A plus m of B plus u of B is equal to, since they are together now, we call this m of AB and then the speed of AB together, right? Because they're moving as one body. So that will be your equation that we need to replace. So mass of A is given to you by, so A is 4 times the speed was 5 plus mass of B was, let me check, it is 2 and the speed is 4, as you can see here, 5 and 4, right? Now it is equal to, the mass of AB is given by 6 and V of AB we don't know, we need to find that. So let's simplify. 4 times 5 plus 2 times 8, that will be 28. That will be 6AB. So the velocity of AB, that is of them being one body, 28 divided by 6. That will be 4 2/3. Okay, so now since we know this, we can find your final kinetic energy. That will be half, m is a mass of AB, which is 6, speed is 4 2/3 square, and then plus also you have your sphere C, which is still moving, so you have to times 1, and the speed of C was given to you from part B. As you can see, it is 12, so 12 square. So let's find that. So we have half times 6 times answer square plus half times 1 times 12 square. That should give you 137 1/3 joule. Now going back to your main formula, to find the loss, you have to take the initial minus the final. So loss will be 200 minus 137 1/3. That will be about 62 2/3 joule for loss. Or you can write down as decimal place as well. That will be 62.7 joule, correct to 3SF. And that will be your question number 4. So the main takeaways is, whenever you have a collision question, you have to use this thing. Momentum is always conserved. Momentum is equal to mass times velocity. So initial momentum is always going to equal final momentum. So that's the main point when you have collisions in a mechanics question. So by having that, you can find your speed of your spheres and then find the rest from that. And that will be your question number 4. Let's move on to question number 5. So a car has mass of 1250 kg, is moving on a straight road. Now part A, on a horizontal section of the road, the car has a constant speed of 32. So this is your speed and it says constant speed, okay? And there's a constant force of 750 resisting the motion. Now part 1, calculate in kilowatt the power developed by the engine of the car. So to know this, we have to first make a drawing and understand what's happening, and then we can find the values that we need to find. Okay, so first thing first is we have a car. Let's say this is our car, right? It is on a road, for example. Now we have a mass of acting on the car in this direction of 1250 kg. You have to times 10 to find the force. That's something we need to know. And what else is here? So let's check. We have a resisting motion, which is given to you by 750, and we have a driving force in this direction. Okay, so now we have been given that the car travels with a constant speed. So whenever you have a constant speed, you have to understand that you have to know, okay, you have to take this note down. It is equal to acceleration has to be 0. That's what it means. That is very important to understand. Whenever you see constant speed, it means that the acceleration is equal to 0. Now, if acceleration is 0, it means that your resultant force is also 0. So basically, the force that is on the left and the force that is on the right, they equate to 0. So, which means 750 has to equal to the driving force. Now, for the driving force, you have to know the formula for that. So we know that power is equal to, so let me write this down, because here we need to find power, so we need to find an equation to join power with the force. So power is equal to FV, so force is equal to PV. So replace here, power is P, V is given to you by 32. So finally, power is equal to 32 times 750. Okay, so the main point here is to make a drawing to understand what's happening, and then understand what does this mean. Whenever you see constant speed, you have to understand the acceleration is 0, and from that point you have to understand that the resulting force is 0, which means the force to the left is equal to the force to the right, and by using that we have to find your answer for P. 32 times 750, that will be 24,000 watt, but you have to give your answer in terms of kilowatt. You have to write down 24 kilowatt. Now let's move on to part 2. It says, given that this power is suddenly, so suddenly means really fast, right? We don't know when it happened, it just happened really fast. Decreased by 8 kilowatts. So what is the power now? Before it was 24 minus 8, that should be 16 kilowatts, which is 16,000 watts. So the power of the car is now 16,000 watts. Find the instantaneous deceleration of the car. So to find the deceleration, we have to understand that we have a resulting force, and we have to find that to find the deceleration. So if you guys do physics, you guys must know that F is equal to ma, and to find the acceleration, we have to find F divided by m. Now m we know already. M of the car is given to you by 1250. So we just have to find this F to find the resulting force. So given that the power is this, we have an equation P is equal to FV. Right. Now P is 16,000. F is, so as you can see, F is the force that we need to find. We don't know. But V is given to you in the question as 32. So the reason why V did not change, because it happened suddenly. So in that instant, the V will not change. So that's why we keep the same V. Now replace, we will have, so on one side we have P, which is this. This is P, of course. We have to replace. F is, we don't know, and V will be 32. F will be what? 16,000 divided by 32. That is 500. So finally, going back to your main equation, force equal to ma. So force is equal to 500. The mass of the car is 1250, A, so acceleration will be what? 100 divided by 1250, that should be 0.4. So let me see if something is missing, because we have to find the resulting force and not the force itself. Okay, so yes, I know something is missing here, because from the drawing we have a driving force and also this resistance, so we have to minus the resistance. So we are missing that because the F here is actually resulting force, not just force. So resulting force is equal to F minus the resistance. That's why we have to replace this by resulting force. So here you will have minus 250. So A will be minus 250 divided by 1250. That will be minus 0.2 meters per second square. Okay, so this force that we found is your driving force because of the power, but we have to find the resulting force by taking off the resistance and then using your formula equal to ma, then find the acceleration. So finally, when you write down deceleration, it is equal to 0.2 meters per second square. Now let's move on to part B of the question to see what we have. So here we have on a section of the road inclined at sine inverse of 0.096 to the horizontal, the resistance to motion of the car is given by this. So let's call this thing F of resistance, given to you by 1000 plus 8V Newton. Now we have to make a drawing to understand what's happening, because it can be confusing sometimes. So this is our ground, and this is the inclination, and this is the ground. So this angle here will be sine inverse of 0.096. And let's say your car is somewhere, let's say this is your car, for example. Okay, let's draw your car like this, no problem. So first thing we can do is let this equal to theta. So from this we get sine theta is equal to 0.096. Okay, no worries. Now next step is to understand the rest. We have when the speed of the car is v. Okay, so the car travels up this section at a constant speed. So again we see constant speed, which means the acceleration has to equal to 0, with an engine working at 60 kilowatts. So the power here is equal to 60. So write down power 60, 123 watts. That is given to you. Now, as you know, when the car goes up, say the car is moving up, this has to be your driving force, and this has to be your FR. And then finally, we also have the component of gravity that is acting on the car as well. So that will be, let me write this down here, that will be in this direction, that will be equal to Wg, and that will be sine of theta. Okay, now Wg is what? It's just the weight, the mass times, sorry, it's mg, not Wg, because W is equal to mg. So m is the mass, which is 1250 times 10. That will be your weight. Now let's replace the values in the equation. Because it is traveling at a constant speed, we have to have acceleration equal to 0. Now because our acceleration is 0, it means that your resultant force is 0. So the force going up is equal to your force going down. So let's write this down. So the force down will be Fr plus this one, mg sine of theta is equal to the force going up, which is your driving force. So replace. Fr is given to you by 1000 plus 8V, and this is 1200 sine of theta is equal to driving force is given by your power. So as you know, power is equal to what? Fv. F will be equal to P divided by V. So that will be P is 60,000 divided by v that we don't know. Now let's simplify. This is from this part, we have seen that sine theta is equal to 0.096. So replace, you will have 1000 plus 8v plus what? 0.096, that will be 1200, equal to 60,000 divided by v. Now simplify, we will have so 2200 plus 8v equal to 60,000 over v. Now we can just cross multiply. You will have 2200v plus 8v square is equal to 60,000. Now let's move everything to one side. You will have 8v square plus 2200v minus 60,000 equal to 0. Now we can just divide everything by 8. You will have v square plus 2200 divided by 8. That will be plus 275 minus, that should be 7500 equal to 0. Now this one is a simple quadratic equation. We have to just factorize. So v square is just v times v. And what are the factors of 7500? We just have to try. You will see that you will have 7500 divided by 300. That will be 25. So 300 times 25, that will be, to get plus 275 has to be plus 300 minus 25. So v can be minus 300 or v can be 25. So we reject this one. So your v has to be 25 meters per second. Now let's say if you don't know how to factorize, or if you just think it's taking too long, you can always use your formula to get the values, which is v is equal to minus b plus minus b squared minus 4ac divided by 2a. So you can always use your formula to find those two values, and from that there will be your value of v. Now the main point here is always make a drawing so you can understand what's happening. And whenever you have mass and everything, always write down the components of your mass, always write down the direction of your forces, and of course the main point is also when you use F equal to ma, F is the resulting force, and whenever you see speed is constant, it means that the acceleration is 0, and it means that the resulting force is 0, which means that the force down and the force up are the same. Okay, so on this note, that will be your question number 5. Here we have a particle P move in a straight line, and the velocity v at time ts is given by these three equations. As you can see, there's three parts. This is part 1, part 2, and part 3. Okay, so this is a straight line from what you can see. This one is a maximum curve because it is negative, and this one is also a straight line. So for this one, let's see what is the shape of this curve. So that will be, so we can factorize this. That will be something like this. Now on the, this is t and this is v. On the t-axis, the value of v is 0, so t will be equal to 6 and t equal to minus 6. So basically it will cross the curve at those 2 points, minus 6 and 6. And when t equal to 0, the value will be 36, so it will be up here. So you will have a shape like this. Now from what I can see, we only start defining this part of the curve when after 5. So 5 will be about here, but after 5 it keeps going down. So what is the value at 7? So we have 36 minus 7 squared. That should give you minus 13. So basically we see that at the value of 7 it will come down to minus 13. So it means that our axis will also going to be negative, so we have to prepare for that on our main graph. So let's draw the vertical axis first and then our horizontal axis. That will be the vertical one, and let's draw the horizontal one as well. That will be your time. in seconds, and this is your velocity in meters per second. Now for the first part, pretty easy. When the value of t is 0, the value of v will be 1. Let's say 1 is right here. Okay, that is the starting point of this movement for the particle, right? And then now we have to find the value of v when time equal to 5. That will be 2 times 5 is 10, plus 1 will be 11. So let's count. 1, 2, 3, 4, 5. For example, 5 is here, and the value should be about 11. Let's say it's here. So since it is a straight line, you have to join them together by a straight line. So that will be the first part of your graph. So we can just indicate that by the line, and then moving forward, you see that the value comes to this curve now. So at the point where, so 5 is this point, so 6, what is 6? 6 will be at the point 0, so 6 will be, let's say this is 6, and 7 will be the curve, right? Because the curve is only defined between 5 and 7. So from this, 5 and 7 will be the curve. Now, we know that the curve goes to 0 at this point, and when it is 7, it goes to minus 13. So 7, let's say minus 13 will be about this point. So let's say it is about this value. So now, of course, when you draw this, you have to show the shape kind of curvy. It will not be a straight line. Make sure you show that it is kind of curvy. Okay. So try your best to make it look kind of curvy. Okay. So that will be for part 2. Now for part 3, again, this one will be a straight line. Let's find the value of v when t equal to 7. So 2 times 7 minus 27, that will be minus 13. So you will begin at the same point. Now what is the value of v when t equal to 13.5? That will be 0. Okay, 13.5, let's say, will be about here. So this one is a straight line. We have to join that by a ruler. Okay, so here you go. That's it. So we can definitely mark those points by dotted lines. Okay, so that will be your graph, the two straight lines and joined by a curve going down. Now let's move on to part B. Find the acceleration at the instant when t equal to 6. Now, so you have to know when t equal to 6, where is your particle? Your particle is at stage 2 when it is this equation. So basically, we know that at t equal to 6, v was equal to 36 minus t squared. So to find the acceleration, E is equal to dv by dt, which is 0 minus 2t, which is minus 2t. So we want to find the acceleration at time equal to 6. So minus 2 times 6, that will be minus 12 meters per second square. That is your answer for part B. Now let's move on to the last part of the question. So we have to find the total distance traveled by P in this whole interval. Now, we have been given a velocity time graph. So as you guys know, the distance traveled will be area under the graph. So let's write this down. Distance traveled is area under graph. So because the area under graph is defined by different equations, we have to break it down into pieces and then we can find them separately. So this is called as number 1, this is number 2, this is number 3, and number 4. Right. As you can see, this one is a triangle, so we can find that half times base is what? 13.5 minus 7. That will be 6.5. The base is 6.5, and times height is 13. That will be area of number 4. So half times 6.5 times 13. That will be 42.25. Now we can find the area of 1. because one is a trapezium, these two sides are parallel and they have a distance in between. So area of trapezium will be half times sum of parallel sides. This is what? This is the value of 36. Let me check. So I think it's not 36 because 36 is the curve. This one should be 11 because we replace here this value here, 2 times t plus 1. This is 11, not 36. 36 is the curve. Okay, that will be, the height here is 11. This is 1. Sum of sides will be 1 plus 11, and times the height in between, that will be 5. So let's see what we get. Half times 12 times 5, that will be 30. So number 1 is 30, number 4 is this value. We have to find number 2 and number 3. Now, how do you find area in the graph? For a curve, you have to use integration. So let's do that. So as we know, the curve is equal to v is 36 minus t squared. Now for number 2, it is in between the value of 5 and 6. Sorry, 6 will be up, 5 will be down. Sorry. Now the curve is 36 minus t squared with respect to dt. Integration will be 36t minus t cubed divided by 3, and the limits will be between 6 and 5. Now we just have to replace to find the corresponding value. 36 times 6 minus 6 cubed divided by 3, and everything minus this one, which is 36 times 5 minus 5 cubed divided by 3. So let's find the value one by one. Divide by, that will be 144 for this one. And how about this one? 36 times 5 minus 5 cubed over 3. That will be 138 1/3. So 144 minus answer, that will be 5 2/3. That will be your area for number 2. So let's check again, because you can always make mistake in those kind of questions. So 6 cubed divided by 3. 6 times 6 minus answer, that will be 144. That is good. 5 cubed divided by 3. 6 times 5 minus answer, that will be this one. So 144 minus answer, that will be this one. Okay, so area number 2 will be 5 2/3. Now, because the area is above the horizontal axis, this area will be positive. However, area, we are talking about the distance, not the displacement. Because of that, it will always be positive for the area. Even if we have negative value, we will take positive values because we are only finding the distance traveled and not displacement. Okay. Now for area number 3, it will be between, as you can see on your graph, it is from 6 to 7. So the limits will be 7 and 6, and it is the same equation. We just have to change the limits to the required values, 7 and 6. That will be t, of course. So first one is this minus this cube over 3, then minus 36 times 6 minus 6 cube over 3. So for the first one, minus 7 cube over 3, 137 2/3 minus, this is the same as this, so 144 minus 144, that will give you minus 6 1/3. Now because we are trying to find the distance traveled, it is a scalar quantity, so we will take the positive value of this. Okay, so finally we have all the things that we need to find the distance traveled. Number 1, we have seen it was given by 30. Number 2 is given by 5 2/3. Number 3 is 6 1/3, and number 4 is 42.25. So finally, distance travel is to add everything together. So first one is 30 plus 5 2/3 plus 6 1/3 and plus 42.25. That will give you 84.25. So that will be in terms of meters because your unit was meters per second. Now that will be your distance traveled for this particle. And that is your last question. So I hope that was somewhat helpful. And as always, thank you for watching. I will see you soon.